Hey everyone, hope you're doing well. Thanks for joining this OPSWAT presentation on mastering perimeter defense. Today we're going to talk about how OPSWAT could hopefully help you in protecting your infrastructure from malware attacks. I'm James Nielsen. I'm the Vice President of Europe for OPSWAT, and I'm supported today by George Cheriches, who's the much more capable sales engineer lead for the European region. Next slide, please. So today we're going to take 30 minutes or so and then maybe move into a short demonstration to try and cover, one, who is OPSWAT. When I present at seminars and the likes, there's a lot of people in the room maybe haven't heard of OPSWAT before, so I'm going to run through who OPSWAT are real quick. Then we're going to touch on why OPSWAT is unique, I believe, in cyber, and how our technologies come together to help you protect your infrastructure. Then we're going to look at some of the enterprise solutions that we have to where those technologies can be deployed to help you protect your infrastructure further. So let's get into OPSWAT. So unbelievably, for a company that many people don't know of, we are 20 years old in January next year. We're selling and operating in over 60 countries around the world, and we have close to 1,600 unique different customers that are largely focused on critical national infrastructure. We're now close to 700 employees. We haven't broke through 700 yet. We're getting close, and nearly 400 of those are engineers dedicated to developing and improving the products as well as releasing new ones. Some of you may not know, but we have quite a large OEM business as well. We believe we look after about 100 million, possibly as much as 150 million endpoints through our OEM solutions, which the likes of Cisco, Palo Alto, Netscope and the likes OEM from us, and they use us to do compliance checking on the devices before they allow it onto their zero trust networks. So many of you out there today may well have an OPSWAT client running on your machine that you're unaware of and is OEM through some of those large vendors. Separate to that, we also have a training academy. The academy is focused on operational technologies and has a whole host of courses and training material dedicated to upskilling people in operational cyber technologies. So a little snapshot of OPSWAT. Been around for 20 years, very stable company, very large and mature client base, and we have grown steadily through those years. We kind of break even as a company. We're not overly leveraged, burning through investor cash. So a very, very stable company to partner with. Next slide. I think I touched on this, but in terms of our industry that we typically serve, it is the world's critical national infrastructure. That's some of the largest financial and insurance companies in the world, as well as defense and intelligence, as well as industrial, energy, chemical processing, power plants, etc., etc. That is the space that we focus on and market to. Although really anybody with enterprise class cyber requirements is a valid customer. In terms of our global presence, you can see the offices. We offer 24/7 support, and we're operating in every continent to support our global customers. So why OPSWAT? Well, no, every organization is bombarded with malware attacks, and just the prevalence of malware is increasing year on year. I think we're now well over 1.2 billion attacks in 2022, and I'm sure we'll increase on that in 2023. And by attacks, I really mean unique malware variants. The majority of that malware is delivered through files still, and there's a lot of ways organizations get attacked, but malware is typically delivered by files at least 80% of the time, and 62% of malware attacks come in PDF forms, Word documents, or executables. The philosophy at OPSWAT is trust no file, trust no device. We kind of take a zero trust approach to files, and that's what we focus on as an organization. Next slide, George. How we do that is with our MetaDefender core set of technologies. I'm going to pass you over now to George to run through the different technologies that build out MetaDefender, and then move on to where those technologies can be placed on your networks to provide protection. George, do you want to take it away from here?
Yes, thank you, James, and thank you everyone for joining today's webinar. It's my pleasure to introduce you the actual technology that we use. So what you see here, it's our core technology engine. Right, so it's essentially a platform. We usually deploy it on a virtual machine in our customer's network. It can also be deployed as a Docker container. The purpose of the platform is really to combine technologies that would analyze the files for malware and provide either a clean file at the end or a very extensive report on that file. And then we'll discuss every of those technologies in details and how we can actually leverage that in reality in a production network. So starting with the multi-scanning, essentially the concept there is quite simple. What multi-scanning is just a combination of different AV engines, so antivirus engines. And the reason we're doing this is actually quite simple. So I'm sure all of you are familiar with EDR, XDR technologies, MDR technologies, whatever you want to call them, right? Endpoint products. Now, they're fantastic, right? But when the AV engine works on an endpoint, it can actually leverage a lot of technologies to determine a file is malicious or certain activity is malicious. The problem is when you actually start using that technology for files in motion, right? You lose a lot of the context, right? You lose a lot of those technologies that you can use on the endpoint just because you can't really observe the behavior of the file since the file is just traversing the network. This actually translates in a lot lower detection rates when you take that technology from the endpoint and start using it at the network level as a gateway, maybe, right? So that's really what we're trying to fix here with multi-scanning by combining over 30 different antivirus engines, all the the big brands out there that you're familiar with. We would combine them in an engine really that can make them run in parallel to scan every file you send at the platform. That also translates into combining different technologies, right? So we're not only using static analysis is a static analysis type of technology, but we're not only using simple things like pattern matching or signature based detection, right? Those AV engines would use heuristics, machine learning algorithms, emulation, and so on and so forth. So we're actually leveraging a lot of the technologies that every vendor has to crowdsource that type of intelligence and put it to work to determine if that piece of file is malicious or not. So the more AV engines you add, the better the detection rate is, as you can imagine. But on top of that, what's also very important is not only to detect more malware, but to be able to detect more malware quicker. Right? So if in the case of an outbreak or some sort of a targeted attack, the earlier you detect that type of malware, the better it is, right? And that's what multi-scanning gives you as well. So it's a kind of like twofold type of advantage, type of solution. More malware detected in a shorter time span, really. And the false positive rate is not really proportionate with the number of AV engines, as you might assume. The actual false positive rate is actually quite low, and there's obviously mechanisms to deal with it. Now, some of you might kind of like think on how is this looking from a commercial or licensing perspective. Well, we have this into packages really. And everything is on premise. I maybe haven't mentioned this. Everything's on premise. Everything can be deployed in the air gap side of the network, so it can work without internet access. And there's obviously a way to update those AV definitions in an offline environment. And this is why OPSWAT is so popular in very sensitive type of customers. And here we're talking intelligence agencies, Ministry of Defenses, and so on and so forth, where we need to be deployed in a secure network that doesn't have direct internet access. Now back to the AV Engine offering. It comes into packages, just like I said. So we start with 8. That's the minimum. That's really the standard that takes you over 90% detection rate, and that's really where we want to start from. We can go all the way to what we call Meta Defender Max, which includes 33 different AV engines, and that pushes the detection rate closer to 100%. Those 100% are actually calculated in a simple way, where we take the top 10,000 most popular malware of the month, and we scan them with the different AV engines, the different AV engine packages that we have, and this gives us that detection rate per AV engine package. Now, how we choose those AV engines in every package is actually quite interesting, and it's just not randomly done. We try to add AV engines from different parts of the world in every package to give you a distributed geographical coverage of every package. So that translates into better response time in detecting outbreaks. So if there's an emerging outbreak coming from North Korea, we've got a South Korean vendor in our base package, so in the 8 AV engine package, to help detecting that type of attacks. And the story goes on, so you can see the map with the distribution of those AV engines and their headquarters and the R&D centers. And obviously for our US and European customers that have concerns in let's say the origin of some AV engines and their reputation, we have dedicated packages that excludes some of those engines from countries under US embargo, for example. So that's the multi-scanning side of things. It's quite simple and straightforward to understand. So essentially just multiple AV engines working on premise, scanning files against malware, static analysis, right? Second technology we bring into the mix, it's called deep CDR. And CDR stands for content, disarm, and reconstruction. And what we actually mean by that is the actual technology takes files, breaks files apart to their native components, removes anything that can run code in a document, right? And this can be over 150 document types or file types. Could be any productivity file, it could be any image or any media file, archives, and so on and so forth. So quite a very good coverage, I'd say. It does this from a purely protective perspective. So it's not based on detection, it's pure prevention. We never try to determine if the macro is malicious, if it's exploiting a 0-day, and so on. The reason we don't do that is we have other technologies that can do that in the platform. But we need a technology that's very efficient against 0 days, right? And the way to be efficient against 0 days is to apply the same philosophy like we have for user access, right? The zero trust philosophy. We do the same, but for file security, really. CDR is almost like a zero trust technology for file security, where we assume everything's potentially malicious. Every code that runs inside the document can exploit a 0-day vulnerability that cannot be detected with multi-scanning, sandboxing, and so on and so forth. And what do? We just remove that, reconstruct the file without that component, and we generate a new file that's used by the users. So the file that's generated obviously has the same content, so the text, the images, what the user's after, but the file, once opened on the endpoint, cannot run any code. And this is fantastic, right? We have a static technology, static analysis technology. We have a pure prevention technology. What can we do more? Well, I'll tell you in a minute, but I just want you to have a visual on what CDR does and how it looks like. So this next slide kind of like represents the intricacies of sanitization and sanitizing a file, really. And the reason we call it deep CDR is really because it's a recursive technology. So it often happens that inside a document you will have other embedded objects, right? In a Word document, you can add pictures, but you can also embed Excel spreadsheets and so on and so forth. So what's really important is to apply the same technology to all the content that's inside that document. And if you only do that at the surface, it's not good enough, right? So it has to be a very thorough approach, and that's really what Deep CDR does. It looks to the very last component in that document, sanitizes everything, rebuilds the file with all the components that should stay, and that's the file that's generated for the user. Right. I was saying, what else can we do, right? Let's assume there's a situation where you might want to keep some of that content because the CDR engine is configurable, right? It's not a black box type of approach where we remove everything and we don't care about the content that's there. We do understand there's business needs, valid business needs that might require you to keep some of the macros in documents and so on and so forth. But how do you keep the macros without taking a big risk, right? You obviously have the multi-scanning piece, which is going to analyze the file and determine if the macro is malicious or not to some extent. But we need something more, right? We need essentially dynamic analysis. And you can do dynamic analysis through sandboxing technologies. And we as well, we have a sandbox technology. The OPSWAT sandbox is, however, slightly different than a traditional sandbox. Many of you might be familiar with traditional sandboxing technologies, where essentially you have a hypervisor that would create virtual machines for you to be able to detonate the file in a controlled environment. The behavior of that file is going to be observed, and everything's going to be gathered in a report at the end, which is going to be made available to the admin. There's some issues with this approach, right? And while this is the most popular approach to sandboxing, there's issues, right? And it's almost like a legacy solution. The issues, or the biggest issue to start with, is a lot of malware has built-in anti-VM evasion techniques, really. So you can determine if the file is running in a control environment, in a sandbox, let's say in a virtual machine. And you can choose not to execute the malware because you're going to be caught, right? You're going to be detected. Now imagine you're a nation state actor. You've invested maybe hundreds of thousands of dollars or maybe millions of dollars. You put maybe 6 months, a year worth of work in developing that type of attack, like it has happened in the past. Obviously, you have to make sure you're not going to get detected. And how do you get sure you're not going to be detected? You essentially run the sample that you developed against multiple AV engines. That's one. Second one is you try to run the sample to multiple sandbox solutions, and you fingerprint those sandbox solutions. There's specific things on every sandbox that allow you to determine the type of sandbox, maybe the vendor itself. So you choose not to execute. That's also one of the reasons why there's hardly any sandbox vendors that have a free service on the web that people can access and upload the file and test for free the solution. So that's really the purpose, right? Or that's really the reason, right? Vendors try to avoid their technology to be fingerprinted by threat actors, sophisticated threat actors, to be more precise. So how are we different, right? What do we do different in terms of sandboxing? So we choose to take a different approach, and we're not using virtual machines and hypervisors, but instead we're leveraging the latest advances in technology and processing power and so on. we actually build an advanced emulation engine, which allows us to emulate components of the operating system, different applications, to allow the file to detonate in a controlled environment, but without having the virtual machine context, right? So the benefit of this, it's actually, it cannot be fingerprinted because there's no virtual machine involved. But the other benefit is it's a lot quicker. It's about 10 times quicker than a traditional sandbox, just because we removed that virtual machine and hypervisor overhead. And obviously, the benefits of emulation technologies are obvious. It's a lot faster than virtualization itself. So essentially, anti-VM techniques don't work against the OPSWAT sandbox because it's full emulation, and it's 10 times quicker. Not to mention that obviously using emulation, it's a lot more friendly, let's say, with the resources, in the sense that you only need on average 10 times less resources to scan the same volume of files um, compared to a traditional sandbox. So just to put things into perspective, you only need 16 GB of RAM and 8 virtual CPU cores to put 25,000 files a day through the sandbox. So actually, that kind of like helps us scale the sandbox. Scaling, it's another problem with traditional sandboxes, which is somehow fixed if you take this emulation approach. We're obviously combining lots of technologies into the sandbox as well, so we can integrate the same multi-scanning technology. We obviously use Yara rules. We do dynamic analysis based on emulation, and that works for Windows, Linux, and Mac OS. We do some Android as well, so it's cross-platform, and you get full visibility into the IOCs that we extract. By the fourth technology I want to be talking about is our SBOM, software bill of material, and why is this important? So to start with, we've seen a lot more supply chain attacks in the news. There's been very big ones that got media attention for a long time, but there's also regulations now that kind of like force organizations to have a software bill of material, or at least to keep track of the components of the software that they're using. The OPSWAT software bill of material solution has the ability to scan source code and also scan containers or container images. So we're talking about the likes of Docker containers, of course, right? And what it can do is it actually shows the list of dependencies or the libraries that make up that software and their vulnerabilities, right? The associated vulnerabilities, giving you the overview on what the software includes, what third-party libraries includes, and what are those vulnerabilities associated with them. So it empowers you to take actions, knowing what the risk is. So mitigation actions, really, right? I did mention there's obviously regulations now in the US. As you might expect, they're the ones leading this. Every government entity in the US has now to have an SBOM from all the vendors they work with, and that's probably going to trickle down to Europe as well. It might be just a guideline or recommendation at this point, but with NIS2 directive, which is 2.0 version now, we might expect an update on that directive that includes SBOM as well for us in Europe. So that's just gonna happen, right? It's just a matter of time, really, because supply chain is such a big risk that big organizations can't really ignore. this is how it all ties into the actual platform. So the file is being sent, it goes through all those technologies, and at the end we have the either a clean file, or we have the same file with a very extensive report around the actual file itself. Right, but how is this actually used in practice? So there's, to kind of like oversimplify this, there's a couple of ways you receive files in a network, right? Emails, it's one of them, right? It's probably still the biggest attack vector, because it's so popular, right? Everyone uses email, and it's somehow easier to target email users than target users that use different type of tools. So we can obviously insert this technology that I've been talking about into the email flow. So every incoming email or every outgoing email can be analyzed with those 4 technologies. That there's actually 6 technologies. We just focused on 4 of them, um, just because we don't have that much time. But essentially, imagine every email attachment and even the whole email body would be scanned with multiple AV engines. We can sanitize it, so we can remove code and macros from uh, email attachments. And you as a user, you just receive a clean copy of that file. So what this actually means in practice, you don't have to rely on users as the last line of defense in your cybersecurity strategy, right? There is a technology solution for that. There's a technology solution to prevent users opening attachments that might have, malicious macros and things like that. Other ways you can receive files, obviously, files being downloaded from the web, files being uploaded to certain platforms that you might host. All those can go through the same set of technologies. Every file that's being downloaded by your users, or every file that's uploaded from users in the internet to a portal that you host, can be analyzed, can be sanitized, can be scanned with multiple AV engines, can be sanitized, can actually be sandboxed if needed. But more and more users would use, obviously, cloud object storage. Organizations tend to use Amazon S3 buckets. Almost every organization uses OneDrive or SharePoint, or just Teams, right? There's many ways you can share files in an organization, internally or with the outside. You might use a managed file transfer solution to send files to companies you collaborate with. Again, we can integrate into those data flows natively. Right? We don't have to change user behavior. We don't have to ask them to adopt new tools and products. We just plug this technology behind the scenes and secure all those files that are being received or sent by your organization. If we move from this, let's say, traditional enterprise network to something, let's say, a bit more complex, with maybe different parts of the network with different classification or security levels, which is often the case for our military customers, for our defense type of customers, or even government. Now, often or industrial customers per se, they might often have different networks. So they refer to blue and red, low, high, less secure, high secure network. So essentially, there's a part of the network which might not be connected to the internet. It might be connected to the web through the IT network or through the less secure network. And files have to be transferred into that network as well, because you run equipment there. Right? You need to update that equipment. You need to update the operating system in that network, and so on and so forth. And we obviously have solutions in that case as well. So what you see on the upper right, it's the OPSWAT kiosks. The way to transfer files into those networks is usually through USB devices or any other form of portable media. It could be external hard drives, could be CD, DVDs. And we even have customers that still use floppy disks, right? So secure networks still leverage floppy disks. And obviously, we have to have solutions to empower them to safely transfer those files into the network. And we have the same 4 technology engines inside a piece of hardware which we call kiosk. For the UK audience, they might know that under the name of ShipDeep. So it comes into different names, right? The long story short, it's a dedicated equipment that allows you to plug in any portable media. It will scan the data from the portable media and transfer the clean files only into a destination network. So you create a bridge really between those 2 networks to allow you to transfer files in. You can also transfer files out between networks with different security and classification levels. If you look at the let's say lower right part of the screen, you see CDS. CDS stands for cross-domain security. It's really a set of technologies that allow us to transfer data in one direction between networks. Those are usually powered by data diode technologies. So either an optical device which allows data to flow in one direction, and that's just enforced by physics. Really, that optical cable only allows data to go in one direction. As you can imagine, those are heavily used by industrial customers, and they are actually mandated in some industries. So like the nuclear industry, for example, in the US, mandates the use of data diodes, optical data diodes, to connect between networks, right? That's the way to proxy files from a less secure network to a higher security network. And OPSWAT obviously has solutions in that space as well. We do help customers segment their networks through the use of diodes, but also we have the ability to secure the files that are being transferred through those diodes, which is somehow unique in the industry. Just to have that scanning, that payload scanning capability inside the diode, it's a game changer in the industry, right? Before this, customers would have had to go and integrate themselves scanning technologies into diodes, which wasn't an easy thing to do. So that was just in short how we can actually integrate our technology into a data flow or a network. To kind of like summarize it and put it simply, any way you receive files in a network, we can probably connect our technology into that data flow. And we scan with all those technologies the files that you receive or the files that you send from that network. Those integrations are in many cases native, because we partner with a lot of vendors in the industry, right? So this shows you an overview of the different vendors that we actually partner with. Every vendor you see there, it's actually a native integration for OPSWAT, which means we actually plug a security gap in those products. There's missing CDR, there's missing multi-scanning, there's missing sandboxing for those technologies, or all of them are missing, right? And that's really what we do. We come and provide that file security into those products. So I'm sure you recognize a lot of those products. I'm not going to spend too much time on it. I just wanted to leave you with this before we move to the demo, right? Right. And I'm going to move to the demo piece now. So I'm just going to share the screen quickly. And I'm just going to share my second screen. So you should be able to see a dashboard, right? And what you see here is the dashboard from our Meta Defender Core platform, that core technology engine that we've mentioned in the past, where we actually combine all those technologies into one single software. And you can see those technologies here, right? Essentially, those are just technology modules that you can license individually. You can combine all of them and then put all of them to work in a workflow really on how we analyze the files. So 33 AV engines, we have the deep CDR technology, we have a DLP solution, we have the sandbox technology as well, and the software bill of material, which is leveraging our file-based vulnerability assessment technology to provide the vulnerability context for the libraries that we're actually extracting from the software that we're analyzing. What I will show you in the demo is actually quite simple file scan where I just upload the file manually. The purpose of this is for you to understand the file journey into the system, right? This happens behind the scenes. This is not something the end users will see. You don't have to worry about this, but this is really important to understand the power of OPSWAT. So for that, I'm just going to go here and say, pick a sample. And I can actually go and select this geofencing attack, right? So this is a password protected file because it's an infected sample. It's a real malicious file. And what I can do is actually choose to scan this. So as you can see, I have multiple workflows, and every workflow includes or excludes some of those technology modules that you see here. First, I want to show you multi-scanning and sandboxing. And for that, I'm going to choose the appropriate workflow. And what you're going to see here is actually the sequence in which the file is being analyzed. File is being uploaded to the system, and you can see immediately we start extracting content from it. Why? This is obviously an archive file. Actually, this is a Word document, which is an archive. Essentially, it's a container for other objects. You see them listed here on the left. So we extract 19 objects from this Word document. 2 of them are being marked as infected, right? Now, the overall file is blocked as with the result as infected, right? But we can look into it and understand why. So here we have the multi-scanning side of things. The ActiveX object, which is the macro, is detected by one of the AV engines that we have, and you can see the name of that AV engine. That goes to show why multi-scanning is important. There are objects here that can only be detected by 1, 2, 3 AV engines and so on. This other object, which is again the .bin object where the macro runs, is detected by more. I think it was 14 out of 33. So more AV engines detect this. However, it's not something that's state of the art. It's not a very new type of attack. And this shows again why multi-scanning is important, right? It gives you that context. The sandbox was the next step. So we actually, what we do is we emulate this in a controlled environment, and you can see we extract, we show the threat indicators here, but we have the option to open the full sandbox report. And the sandbox report, I don't want to get too technical here. I just want to show you essentially the overview of the threat indicators, right? We emulate this and we understand that this Word document is going to launch PowerShell. Right? That's suspicious. It shouldn't happen. Then we see there's a lot of calls to the system, right? Functions that are being called on the operating system excessively and so on and so forth. Then we map this against the MITRE ATT&CK framework. And we build this nice graph that explains the most important actions that are being taken in this emulation process. So essentially the behavior of the file. And what's interesting about this file is actually that once you open the document, it's going to try to geolocate you. So based on the IP address, it's going to try to understand what country you're from. Why? Just like the name says, this is a geofencing attack, which means it's only going to attack specific IP ranges, so specific countries. Next thing, it's going to start the PowerShell process, and you can see here the PowerShell is going to go to this web page and download the file, which we also capture here as network activity, and you can see the new file is actually dropped on the user system. Obviously, that's all suspicious or malicious activity that shouldn't happen, and therefore, with a confidence of 100%, the sandbox says this sample is malicious. So on top of multi-scanning, which just says, yeah, this is malicious, this is the malware name, the sandbox gives you this whole context, right? This is what the malware does, right? This is why it attacks you. If we look here, there's actually a lot of things that we can observe about this file. Might not have time to go through this actually, but that's actually quite important. I'll just quickly show you here. Just going back to why emulation-based sandboxing, it's has some advantages over traditional sandboxing. So for example, here the malware tries to determine how many files were recently opened in Microsoft Office. Right now, obviously, if you create a new virtual machine to just detonate a file, that number is going to be low. So that's one sign for the malware. It runs in a controlled environment. It runs in a virtual machine that was created for that sole purpose of detecting the malware. And obviously this goes on. You can see how many things this malware checks against, right? The whole purpose of this is to actually be able to run on a user endpoint, on a user laptop, and not run in a controlled environment, right? The likes of an Amazon environment. Why? Sandbox vendors that provide SaaS solutions, they usually host their technology in AWS. So you can see the amount of information that's being provided by the OPSWAT technology here. Right. Just going to show you another quick example here. On data sanitization. So this again, it's a malicious file. It's a Word document, and if I were to analyze this document again, you can see this is infected, and what we can see here is that the document is sanitized, which means the ActiveX control gets removed. The ActiveX control is just macro, really. The images, we take them out, we process them, we create a new document, which I can manually download here. And I'm going to just bring it on the screen. This is the sanitized version of the file, right? This is what the users would see, right? It's now safe to open on my machine because everything was removed. It was de-weaponized. There's no content that can run on the machine, right? There's no macros, there's no code that runs on the machine. The images that we took out, we put them back. So they're in the same place where they should be. Just mindful of the time. I just want to show you one last example for the software bill of material. That's like I said, that's really important. And for that, I'm just going to analyze this file and process it with a different workflow that includes the SBOM technology. So we're not only going to try to determine if there's vulnerabilities in this software, we're also going to scan it against malware. So you can see this is malware free, but some of the content has known vulnerabilities. So if I click on it, it gives me the packages that include vulnerabilities, gives me the CVE ID and the level of vulnerability, so how critical it is really. So this allows you to prioritize really on what should be fixed. Another way to use this technology is in the software development lifecycle type of approach, where you might have a shift left strategy and you want to do all this analysis at the beginning of the development of certain products, and OPSWAT can help with that as well. So thank you for paying attention so far. That was the demo and the presentation we had. I hope it was meaningful and you have enjoyed the content. We're happy to take questions if there's questions from the audience. So I can see a question from the audience. How does OPSWAT's approach to endpoint security differ from that of other vendors? So what we do is, and James, please feel free to jump in. What we do is actually we use those endpoint technologies in our platform to do that scanning at the network level. So we're not an endpoint product. What we do is the whole analysis, we push it to the DMZ. And the whole point is to not allow files into the network unless they've been through this very extensive check against malware. It's not only the AV engines that we use in the DMZ, it's the sandboxing, it's the CDR, and it's the whole set of technologies. You obviously keep your EDR products, your endpoint products. We're not replacing them. We're not offering the same solution. Really, it's just another way to provide better security at the network level. Really.
Yeah, George, just to add, that's it for me. We're not an endpoint protection technology. We protect before the malware hits the endpoint, or by scanning storage, or by scanning on various network locations.
Perfect. I have Cisco equipment. Is it possible to integrate OPSWAT with Cisco? Depends on the context. We do have a NAC solution as well. So at OPSWAT, we have over 20 products. And network access control is one of them. And we can integrate with Cisco equipment if we're talking about managing access to the network. So we can do that. There are ways to integrate with Cisco technologies. So integration between OPSWAT and Cisco technologies is possible. We just need to be a bit more specific on this, and we can obviously help with information. Short answer would be yes.
Thank you very much. Perfect.
Yeah, sorry, on the Cisco, the short answer is yes, George, right?
Yep.
Whether it's the load balancers, the proxies, whether it's through ICAP or through some of the APIs that we have, there's a number of ways. We just need to understand where.
Correct.
Can I only use deep CDR? Do I need multi-scanning? That's a great question. It comes up quite a lot. George, do you want to? No, I'll let George answer it.
All right. So yeah, I can give it a try. So the short answer is yes. From a licensing, a commercial perspective, you can only license deep CDR. What deep CDR is going to give you is a clean copy of the document that you can use, a safe copy of the document that you can use in your network safely. What you're missing by only using deep CDR is the context, right? You will not know if you're under attack. If you will not know you're maybe targeted. This is the information that's provided by either multi-scanning or sandboxing. So it's the context really that you're missing. You'll still be secure, but you might want to know that you're under attack to adjust some of your policies and strategies. Not necessarily for that data stream that we protect. That might be just one way the threat actor is trying to get you. But there might be other ways where OPSWAT is not maybe connected that could potentially be exploited.
Great. The next question is how password protected files are addressed.
So the platform itself supports password protected files. It depends on the integration itself. The Meta Defender Core platform has a REST API interface, which is very used in the finance industry, for example, for integrations with different banking applications or CRM solutions. And then when the file gets uploaded, if we're provided the password, we're gonna process the file, and we can even sanitize it and keep the same password for the sanitized file. If it's email, if it's the OPSWAT email integration, it's even more interesting. Usually the attachments that are being sent to emails that are password protected in, I don't want to say all technologies on the market, but most of them, they just block the attachment if it's password protected. And then you as a user, you have to reach out the internal IT support to ask for that email to be released. We have a different approach in the sense that we just remove the password protected document, we provide you a link that you can click to insert the password. So it's like a self-service portal almost, where you just put the password and everything happens behind the scenes. We'll use the password. We go back, we rescan the attachment with the password that you provided, and if everything is fine, we'll deliver you the clean email with the attachment to that email.
Lovely. Thank you, George. If you're an end user, what would you recommend for a standalone system?
So that's somehow vague as a question. So as a standalone system for OPSWAT, or in OPSWAT terms, it's really a deployment where we don't have internet access and everything happens on that box, right? Standalone could be the OPSWAT kiosk, where everything happens in terms of scanning. Everything happens on the kiosk itself. The advantage of that is you don't have to connect it to the network, and obviously there's reasons for what you wouldn't want to do this. It's either not possible, or there's might be security concerns. Um, so we have solutions for that, but I don't really know or understand the context of the question to be able to be very specific.
Fair enough. Thank you, George. Just being
Sure.
mindful of the time. A few more questions. How long does it take to run the files through 8 AVs, CDR, and file scan?
Right. So if we're talking antivirus detection and CDR, we're talking seconds, like 1-2 seconds per file. And here I'm just being very generic, right? Say PDF of 2 megabytes, 1-2 seconds to get it sanitized and scanned with multiple AV engines. Obviously, when using sandboxing, that's a lot more expensive and lengthy process. But it's still a lot better than what we have in the industry. On average, we can sandbox a file in about 20-25 seconds. That's really what we got from our statistics. And I'd say all in all, if we use all the technologies that we have, it would be under 30 seconds per file. But we really need to understand the use case before we recommend any of those technologies, right? What we provide is really tailored solutions to customers. So we need to understand the pain. We need to understand why we need what we need to solve, right? And then we'll suggest the best solution. But I hope that answered your question. So it could be anything from 1-2 seconds to 30 seconds, depending on what technologies we're using.
Sure. George, just is it Web Sussman just came back? So they're asking if your grandmother has a computer and needs protection. Do you provide a solution? Short answer is no. Go to one of the endpoint malware vendors for that. That's not what we're doing. We're providing protection to enterprise customers before it gets to their servers or endpoints. Another question: any integration or usage of exploit DB on OPSWAT solution?
Not that I'm aware. Just need to check what exploit DB is actually. There's nothing that. Well, this is not something that I'm aware of.
It looks like a vulnerability database.
Yeah. It might be used in our vulnerability engine. So for our vulnerability detection engine, we actually use a number of databases on the web, and this could very well be one of them. I don't want to say no or yes or no without knowing, but the answer is we leverage multiple sources for vulnerabilities coming from third-party organizations, NGOs, or vendors themselves to provide that vulnerability assessment.
Any more questions, anybody?
Got one last one. Can we CDR video files?
Yes, we can. Yeah, we can CDR both video and audio files. There's also a very good blog post on the OPSWAT website that speaks about how video files can be malicious. So I recommend you go and check the OPSWAT blog for that. It's actually quite an interesting read, and it's obviously not a very popular attack vector because it's very difficult to exploit video files with malicious intents. But that's something sophisticated threat actors would do. Short answer is yes, and I recommend you go and read on OPSWAT blog about this. I think that's it with questions, right? We're 5 minutes out. Thank you again for everyone who attended. Appreciate the questions and the engagement. And looking forward to see you at the next webinar. James, any closing remarks on your side?
No, just if you want to scan the QR code, you can download our latest web application security report. If anybody wants to get in touch, feel free to reach out on LinkedIn or email me at james.nielsen@opswat.com, or just reach out through any of our channels on our website. I hope that was useful. Thanks for joining, folks. Appreciate it.